If you want to know what kind of shark that is, I got you. And if you're worried about if somebody comes along and saves this poor stranded thing, don't worry. They do end up dragging it back out into the surf and it starts swimming away from the shore. But whether or not it survives and makes it back to where it's supposed to be is a completely different question, because this is not a coastal shark. This is a pelagic or open ocean shark known as the blue shark, Priones glauca. Now, I bet you're wondering, how the heck does any pelagic shark species survive in the open ocean? Isn't it like a blue desert out there? How's there enough food for them to survive? Wouldn't every shark just evolve to be a coastal shark species where there's a ton of productive habitats and a lot more prey? Well, let me tell you about a pretty cool foraging behavioral adaptation in blue sharks that might shed some light onto this. You see, the open ocean isn't entirely a desert. The food is just deeper. It's in the twilight zone, which is the region of the ocean with the largest fish biomass, in fact, which means there's a ton of food there. It also means that our pelagic apex predators have had to adapt to a life of diving to get their food. But deeper also means colder, which for an ectothermic animal like a shark might be a problem, because colder means a lower metabolism, which is great for something like resting and conserving energy. But when you plan on hunting, to be successful, you need to be spending a lot of energy. And so warmer is generally better. So how do these sharks get around this? Break out of the thermal constraints of the twilight zone, blue sharks use mesoscale eddies. In the Atlantic, the northeastern movement of the Gulf Stream leaves behind these eddies. Now, they can be anticyclonic and spinning clockwise, or they can be cyclonic and spinning counterclockwise. Now, if you look at a cross-section of one of these eddies where the y-axis is depth and these colored lines are temperature gradients, what you see is the anticyclonic eddies are actually bringing warm surface waters deeper down like a whirlpool, whereas the cyclonic eddies are actually pushing colder bottom waters up towards the surface. So what do the blue sharks do? Well, they take advantage of these anticyclonic eddies to dive deeper and then ride this warm surface waters into the depths of the twilight zone where all that prey biomass is, but they can still forage within their optimal temperature range. And best wishes to that rescued blue shark, because it has a very long swim ahead of it before it can ride another anticyclonic eddy into the twilight zone.